This is tutorial number 4, Curtailed Water Supply from a Reservoir. It's part of the water management tutorial suite that we have been working on. So if you've been following along, you'll notice that in the previous tutorial we built a elevation volume table here to allow us to calculate the water depth as the volume changes over time. In this tutorial, I'm going to walk through the process of changing the amount or changing the rate of flow depending on a trigger point or a water elevation trigger that's calculated by the reservoir volume. So what this rule will require is that during the simulation we monitor the current depth, and when it hits that trigger value, which we can set, or we can have the user set, then the request for water supply the flow rate will change to a lower flow rate in order to help maintain a low water level in the reservoir. This is an operating scheme that is quite common. It's obviously simplified for this tutorial, but now we will walk through it. To do this, we want to edit the logic that we currently have in the container called water supply. But before we do that, let's look at a time history result to see what's going on. So I'll open up this chart here, which shows us in green the current water depth, which corresponds to the Y2 axis over here, shown in meters. Also, we have the flows. We have the inflow in blue, an overflow in magenta, and this thick red line showing the water supply, which represents the controlled releases from the dam in order to meet this irrigation supply. What it currently does is it runs at full capacity up until the point the reservoir is empty, at which point the flow is equal to the inflow. The water is just simply moving through the empty reservoir at that point. We can zoom in to see what's going on a little bit more. What you see here is that when the reservoir is empty here, the green line, when it hits the empty point, then what we have is that the only controlled outflow we can provide is equal to the inflow. That's why these two lines are on top of each other at this point. Instead of this, what I would prefer that we do is that we set up a triggering point that says when the reservoir volume reaches a certain low water depth, in our case we will say it's 1750.3, which is about where my cursor is pointing, then we will drop this water supply down to a low flow level until we either reach the end of the irrigation season or the water level rises back up to be above that threshold point. Okay, so let's build that logic. To do this, I'll go back to edit mode. You can either click on this edit mode button here or type the F4 key, which is what I just did. Then we can go into the container. I'll go in here. I'm just going to move this over a little bit because I'm going to put some inputs here. So what we want to do is first let's add a couple of inputs. We need to know what the triggering point is, or the water depth at which we hit that triggers the curtailment. And I mentioned that I want to use 1750.3 meters as my curtailment point. So I'll put that as a value in a data element here. So this one, this data element will be called the curtailed demand. Curtailed demand. And then it's liters per second like everything else. And this is the demand requested from the reservoir during curtailment. And let's set this value to 25. Now again, because it is in a data element, this will enable us to expose this input if we wanted to on a dashboard so that the end user of the model could change this value at any time. Typically you want all of your values to be contained in a data element in GoldSim. The next element we want to add, I'm just going to copy and paste this, is going to be called the low reservoir level. Low reservoir level. And this is the level at which point we trigger curtailed demand. Maybe a better way to describe this is if the reservoir depth drops below this value, enable curtailment. Maybe that's a little bit more clear. The units of this are going to be meters, and again, we want to say 1750.3. Okay, with that being done, now we can add our logic. I'm going to use another status element that will tell us when curtailment is occurring. So I'll just open this up and I'll call this curtail on, and I want to emphasize the true value. So what I mean is, when this status element outputs a true output instead of a false output, I want the name of this status to reflect its true status, which in this case is going to be curtailment on. So that's why instead of saying curtailment off, I say curtailment on, because that's the true. That's going to be when this status element outputs a true value, we want it to say on there. Okay, so it's true if curtailment is in effect, false otherwise, or false if no curtailment. Just trying to be clear here. Okay, by default we'll start off false. That doesn't really matter too much. Okay, we only want to trigger the curtailment on if the water level, in our case it's called depth, is less than the low reservoir level. So that's an easy trigger to set up. We can just say on true, just like it was before, but we're going to change the definition here and say when the depth, now I just typed that in, but you could also right click in here, select insert link, and find the depth output, which is inside of the main part of the model, and then just click OK, and then say less than low reservoir level. That's going to trigger a curtailment. The water depth is drawing down below that trigger level, and so that will enable the curtailment. I'm going to copy this expression here because I want to use something similar in the off trigger. So I'm going to the off trigger. Notice it also says status is set to false. That indicates off in our case. Okay, so now I'm just going to copy or paste my previous expression here, but instead of saying less than the low, I'm going to change this to greater than. When the depth rises back above the low level, then we can shut off the curtailment or enable full flow. Okay, now that that's done, we can change our status element to have 3 states instead of 2. Currently, it's just full capacity or 0. We want to add a 3rd state, that is the curtailed flow, if we are in the situation where during the irrigation season, we have a curtailment on. To do that, I'm going to add a switch, and I want it to be the first statement because it's the most restricted statement. And by the way, GoldSim always walks through, starting with the first statement, walks its way down until it hits a true condition, at which point it evaluates to that output on this right side and exits the if-else statements. Okay, so I'm going to, again, refer to the irrigation season. I want the irrigation season to be on in order to enable the curtailment. If it's not even during the irrigation season, there's no reason to even worry about our curtailment. So I'm just going to put that in there and then say and here, because we need both the situations to be true in order to enable curtailment. So the curtailment status is here, curtail on. So if it's during the irrigation season and we have a curtailment on, then we're going to refer to the curtailed demand. Otherwise, during the irrigation season, we will use the full demand, otherwise 0. So those are now the new 3 states that we have. Because our reservoir is already looking at this output, we don't actually need to re-hook up anything in this model. All we did was change the logic slightly. You'll see that there is now a new influence line coming over here from the depth back into there. And that's okay. That's what we want. So now we'll go ahead and run this model and see if we can tell the difference in this plot. And now if we zoom in, you can see that indeed we have this new irrigation flow that's now set to a low flow of 25 liters per second during the time which we are in which the reservoir level is at or below, or actually in this case below, less than 1750.3, and we won't switch back to the full irrigation demand until that level rises above 1750.3. So that's the nice thing about the status, is it can hold its state while until the next trigger point occurs. Okay, so that is the end of tutorial number 4. Thank you for watching, and if you want to continue to see what else we have, our next tutorial is going to be looking at evaporation losses from the reservoir.